Hello, so today we are going to do problems from weekly contest 386, this week's weekly contest. And the second problem is find the largest area of square inside two rectangles. So what's happening here is that we have n rectangles that we get in the input. And what we get as coordinates or as identifying coordinates for the rectangles are their bottom left coordinates and their top right coordinates. So for example, for position I, for rectangle I, the bottom left I is the coordinates of the bottom left position for the rectangle, and then top right is the coordinates of the top right position. So for example, if you look at this first example here, the first rectangle 0 has bottom left 1 1, and then the coordinates for the top right 3 3. So that's why you see here it's this rectangle. And then for rectangle 1, 2 2 is the bottom left, 4 4 is the bottom right, and so these are the two coordinates, and this is it. And that's the core idea here. Now what are we looking for? Well, we are looking for an intersection of any of these two rectangles. So we want to find a square that fits in an intersection of one of these two rectangles, and among all of the squares that fits in any intersection, we want to return the area, the largest possible area of any of these squares. And if there is no intersection, we'll just return 0. So again, let's take a look at this example. What possible intersections that fit here? Well, we have a square with side length 1 that can fit between rectangle 0 and rectangle 1. So what that means basically is this one here. And then we have another one that can fit between rectangle 1 and 2. So this one is between rectangle 0 and 1. So this is 0 and this is 1. And then we have another of side 1 that can fit between 1 and 2. So this is, right? So that's, so both have a side of 1. And so both have area for the square of 1. Because remember, area of square is just the side length square multiplied by the same side length or squared, right? So that gives us a 1 here. If we take a look again at this example here, same thing. We have this intersection. We have this intersection, right? We have this intersection, okay? And each of them is side 1, so we return 1 as the largest square. These one, no intersection at all, so we return 0. So that's the idea. Now, if you look at the constraint, the number of rectangles is 10 to the power of 3. So this means 10 to the power of 6 could potentially pass. So we can try to actually try every pair of rectangles. So just try every pair. Try rectangle 0 with 1, rectangle 0 with 2, rectangle 1 with 1, rectangle 1 with 2. And then see if any of these has an intersection, calculate the square intersection, calculate the area, and take the max, right? So that's the approach we can take, but let's see how we can accomplish it. Okay, so how do we do this? Well, we said we want to just traverse every pair, check every pair, and check if they have an intersection, and take the area of their square intersection. Okay, so that's the idea here. Now, how do we check if there is an intersection? Well, we have this rule here is, instead of checking if there is an intersection, we can check what are the conditions where there won't be an intersection. And in that case, we can say, we can enumerate all the conditions where there won't be an intersection. And then the else is going to return true, because if we find that we determine that all the conditions that say there is no intersections are false, we can return true, because then they must have an intersection. So that's our approach here. Now, how do we determine if there is no intersection? Well, we're going to try to do it by enumeration here. It's either if we have two rectangles, R1 and R2, either one of them is to the left of the other, or one of them is below the other, or both at the same time. What do I mean by that? It's either you have something like this for R1 and something like this. So in this case, one is on the left of the other, or you have one like this, one like this. In this case, one is to the top of the other or below it, and the other, or maybe potentially both, which is something that is like this. So it's on the left and on the bottom of the other one, okay? But for this one, it's actually this, we can detect it with either on the left condition or to the bottom condition. So this one, we don't really need to worry about it. So now we just need to be able to catch this case, one to the left of the other, and this case, one to the bottom of the other. So how do we do that? Well, let's first just do some condition, some naming here. Let's say this is R1 and this is R2. And let's say this, let's name the bottom left R1 of R1 BLX for the X coordinates. And then let me write this. So let's say it's going to be for R1, the bottom left is going to be R1 BLX and R1 BLY, so for the bottom left. And then it's going to be R1 top right X and R1 top right Y for the top right coordinates. And we do the same thing for rectangle 2 for the pairs we are looking for. So this is just the same thing except it's R2. Okay, so now knowing this, let's draw the rectangles in the both conditions. So let's say we have the left one here. And so we would have this one here would be R1, would be this one pretty much. Okay. Let me just say something like, so it's going to be something like this. And for this one, it's going to be this one. For its for its bottom left, and for their top right, it's going to be this one. For this one here, and then for this one, it's going to be let's just put this one here. We will have the same one to the right of it. Okay. Okay, so now knowing these two conditions, let's look at what conditions we need. Well, in this specific case, what we need to check is right one top right X position. We only need to worry about the X position because we only check in the left if it's one of them is to the left of the other. So if this position here, right, if this position here is smaller, so the X position, if this is like, so this position, if it's smaller than this position, then that tells you that one of them is on the left of the other. There is no intersection because there is some sort of gap. Or even if it's here, there is still no intersection, right? So if one of them is smaller, so if the R1 TRX is smaller than the R2 bottom left X, so if this X position is smaller than this X position, then we can say that there is no intersection. Or the other case where it's the exact same thing, except maybe this actually is to the left. Sorry about that. This actually is to the left. Sorry about that. If we just switch the order, then and make this R2. Okay, and make this R2 actually like this, and make this R1, then it's going to be a similar check except the name is reversed, right? So basically the same thing except we check R2 X, so we check the X here, which is R2 TRX, is smaller than R1 BLX, right? So just the reverse condition like this here, okay? And so if that's the case, that means one of them is to the left of the other. Okay, so now we do a similar check, but for the top condition. So this would be like this, and this would be like this. So now when we are checking one of them is the bottom of the other, we are checking only the Y values, right? So let's say, oops, not that. So let's say we have something like this for the Y values. So what conditions tell us that the bottom is below the other one? So either R1 TRY is smaller than R2. So let me actually just draw this for you here. Okay, so either R1 TRY, which is this position here, but on the y-axis. So either this here is smaller, is higher, so in this case here, so either R2, this here, is lower than this here, then that tells you there is this gap, right? So either the top right is below the bottom left of the other one, that tells you that it's below it, or if this was R2 and this was R1, then just reverse it, where basically R1 TRY, this one here would be R1 TRY, is smaller than R2 BLY, right? And so that's the condition where it's below. And we only need to check these cases to find the intersection. If both are not true, then that means there is an intersection and we can return true, okay? So that's the rules for the intersection. Now, how do we calculate the actual rectangle square size or side, right? So that's actually pretty easy because we only need to find the difference on the x-axis. So, for example, the intersection on the x-axis, like this, and the intersection on the y-axis, and of course we need to take the min because we are doing a square, because for example, let's say there was an intersection more, so let's say maybe this triangle was like this, rectangle was like this, then in that case we can only take one side, the smallest side. We can't take the entire dy side, okay? So that's the idea of taking the min of dx and dy as the square length. But then to find dx and dy, so the intersection on the x and the intersection on y, well, for the intersection on x, we only need to take the minimum position between the minimum, this one, right, and this one, and compare. So we take the minimum between their top right corner, so between this one and this one, and we take the max between their bottom left corner, right? Because the intersection is going to happen between the max bottom left corner and the minimum top right corner between the two, right? And so that's what we take here for dx, and we do a similar thing for dy, okay? And that's pretty much it. That's the whole idea. So let's code it up. Okay, so let's implement this. So the first thing we want to do is just do a traversal for both. So how do we do that? So to do the traversal for both, we can just go through like this. So we need to get the number of rectangles, which is just going to be the length of bottom left array, and we go through both of them, right? And this is the best area basically here. And what we need to do is just check if they intersect, but first we need to just for the sake of doing these, we need to define variables for the bottom left coordinates and the top right coordinates, okay? So the bottom left coordinates and the top right coordinates for R1, for the bottom left, we just get it from the bottom left array, and for the top right, we get it from the top right array. And we do the same thing for R2. So we assume here R1 is at index I and R2 is at index J. And we want to check if there is an intersection, okay? And for the intersection, we just need to pass all the coordinates for the bottom left and bottom right of R1, and the top right and for the R1, and same thing for R2. So we pass all of these here. And if there is an intersection, then we just calculate using what we said here. We calculate the square length, okay? So how do we do that? Well, it's going to be like this. So as I said, it's the min of the top right x coordinates between the two rectangles minus the max between their bottom left coordinates, okay? Because this is going to be the higher position in the intersection, and this is going to be the lower position in the intersection. And same thing for y. and then we take the square length, and now we check if this is the best area. So we just take the max between the existing best area and the current area, which is just going to be the square length divided by 2, or the square side length multiplied by 2. Squared, that's what I meant. So that's here, and we return the best area. Okay, so now we need to define the intersection definition. So that's what we do here. So just def, and now we can actually just use what we wrote here, right? So let's just take it up. Okay, so just return true. We check if the conditions where they don't intersect, if any of them is true, we return false because they don't intersect. If not, we return true because they must intersect. Okay, and that's pretty much the whole idea here. Looks good. And that gets accepted. Okay, yeah, and that's pretty much the idea. Sorry, by the way, about the drawing technical difficulties here, but I hope this was easy to understand. And thank you for watching, and see you in the next one. Bye.